In the previous video, we've seen this theorem. But before we go about proving this theorem, let me just give you a simple scenario to illustrate some concepts, and then we will come back and prove this theorem. So let's look at something really simple, and all three here have been satisfied. So if we look at the harmonic series, all the UNs are positive. So remember, UN is this thing here. This is positive. UN, so you're not taking into account the negative. So this here is positive, this here is positive, this thing here is positive. Remember, you're not taking account this negative. You're not taking account into this positive. You're just looking at the UN here. All the UNs are positive, so this condition has been satisfied, and it's non-increasing. Either stays the same or it goes down. Well, this thing here is always going down. It's non-increasing. So this is satisfied, and then it is indeed heading towards zero. The limit heads towards zero as n increases. So you can see that this here is heading towards zero. Okay, so all three have been satisfied. Now let's look at the series. Hang on, I just want to illustrate some concepts that will help us understand the proof. So if you look at the series, if you decide to look at the series from this perspective, let's do it as this. So you've got, so remember, this thing here is positive, this thing here is positive, this thing here is positive. All the UNs are positive. Okay, so you don't take into account the negative. Now, if you decided to view it like this, so you're looking at the series, but view it as this. So one take away a half will be a half. And then this thing here, a third take away a quarter, that will then give you this. And then this thing here will give you this. So here you're adding a positive amount each time. Remember, this thing here is positive, this thing here is positive, and they're getting smaller each time. They're getting smaller each time. So if you view it like this, hang on, if you view it like this, here you're adding an amount. So here you're starting with an amount, and then you're going to add an amount here, and then you're going to add another amount here, and then this amount here is going to be less than this, and then this next amount here will be less than this one because it's getting smaller and smaller each time. So here you start with an initial amount, and then you're adding an amount. You're adding a positive amount because this thing here is positive, this thing here is positive, and this thing here will always be bigger than this thing here. So when you get bigger, take away the small one, you're always going to get a positive amount. So you start with your amount, and then you're going to add another tiny amount, and then you're going to add another tiny amount, and then you keep on adding and adding. So what this is telling us is that it's always increasing, or it could stay the same. So by you looking at this, it tells us that if you sum up everything, it keeps on growing and growing and growing. It's non-decreasing. So by you looking at this, it tells us that as n increases, it's going to be non-decreasing. It's just going to get bigger and bigger and bigger. So it's always climbing. But then, if you look at the very same series, but from a different perspective, so let's look at it. So earlier we did it like this. But then now, if you view it like this, so get this, view it like this, and so on. So this thing plus this thing will then give you this thing. So you've got your minus here. This is your minus here, and then a quarter plus a fifth. That will then give you this, and then this plus whatever's next here will then give you this. So you looking at the very same series, but from a different perspective. Here it tells you that it's bounded from above. You see, you start off with your initial amount, and then you're taking away an amount, and then you're taking away an amount, and then you're taking away an amount. Remember, this thing here will always be positive, so you can't take away a minus. You can't take away a negative here because when you view it like this thing here will be bigger than this thing here. So when you add the two, it will give you a positive number. This thing here is bigger than this, so when you add the two, it will always be positive. So here you start off with an amount, you're taking away something smaller, and then you're taking away something smaller, and then you're taking away something smaller. So what this is telling us is that it's bounded from above. So you have some sort of, it can never be higher than 1, because you start off with your initial amount here, you're taking away a tiny amount, you're taking away a tiny amount, you're taking away a tiny amount. It can never be above this. It's bounded from above by this, whatever this number may be for your sequence. So viewing it one way tells us that it's increasing. It's always increasing. Viewing it another way, it tells us that it's bounded from above. It's bounded from above. So if this thing here is always increasing and it's bounded from above, later on it's going to reach some sort of a ceiling, some sort of limit. It's bounded from above. So and this thing here has to always be climbing. So eventually it will reach some sort of limit. It's being contained within this limit. But I will continue in the next video. Okay.